Now we have what's called a perfectly inelastic collision. We have our same two objects, or at least the same two masses moving at the same velocities as in the last two examples. But this time, when they collide, they crumple together and they're joined. If they're metal or clay or something, they just kind of crumple together and hook onto each other, and now they can't move apart, so that they move off with some common final velocity. We want to find that common final velocity. We first note that the total momentum before collision, P total, is equal to the total momentum after collision, P prime total, which tells us that the total momentum m1v1 plus m2v2 before collision is equal to the total momentum after collision. Now, after collision, we have the two masses joined. They have mass m1 plus m2. They're essentially just a 21 kilogram mass moving at velocity v prime, so that the momentum is m1 plus m2, common mass or total mass, times their common velocity. We can easily solve for v prime dividing by m1 plus m2, and we obtain this expression for the final velocity. It's a simple matter then of substituting the masses and velocities, the two velocities before collision and the two masses, and we see that we have a total momentum of negative 48 kilogram meter per second. That's the initial total momentum and has to be equal to the final total momentum. We're going to divide the total momentum by the mass to get the velocity, and the mass after collision is the total 21 kilograms. Dividing the momentum by the mass, we get negative 2.3 meter per second velocity after collision.